Right. So in today's warm up, we have three equations or three problems, I guess, to do. I shouldn't say three equations. Number one today, we have x plus y equals 4 and negative 4x plus 2y equals 2. So neither one of these is ready to go. So your first job will be to get them in the right format. So here we go. Equation 1, guys. What do you think? Just move x over, correct? Yeah, okay. So we'll subtract x from both sides. That makes it a negative x on the right now. And you still got that 4 that was chilling over there. Equation 2 looks like it's going to take a couple steps to get in the right format, but that's okay. First things first, what's over here besides the y's? You got this negative 4x. Really, let's just move that to the other side. So we'll add 4x both sides. So that would leave you with 2y equals positive 4x plus 2. And you're almost there, but you got the 2 in front of the y, so you're going to divide every term through by 2. So divide everybody by 2 would give you y equals 2x plus 1. Every term divided by 2. And now we got the two equations. Equation 1, equation 2 in nice pretty formats. Go to your calculator, type them in. When you do, and you hit graph, which takes, of course, a minute, but I prepped it ahead of time. It looks something like this. And then you know what to write. It's obvious that they cross, so you write the word consistent, right? Consistent. They're not the same line. So independent, that's the one we write all the time, consistent and independent. And then real quick to find where they intersect. Second calc, intersect, go to about where they cross. And the answer is 1, 3. So jot that down. X equals 1, y equals 3. Consistent, independent. And that's pretty much all there is to it. All right, now let's go back and do number 2. Number 2 is ready to go. If you look at it on the board right up here, it's got y equals x cubed minus 3x, and it's got y equals negative x squared plus 1. So both the last problems, no work needed to find what the equations are. You go to y equals, and you clear out whatever you got. X cubed minus 3x should be in there, and negative x squared plus 1. Of course, you probably have yours up here. I'm just kind of saving space and doing them all at once. But never a bad idea to do a zoom and a 6 and reset your window, and hopefully we'll be able to see them. These are probably going to be funky looking things. It's a cube and a square. Here they are. Oh, look at that. That's kind of what an x cubed graph looks like, by the way, and that's x squared. It's got a negative in front of the x squared, so it opens down, reflected. So I see it crossing at, oh my, let's see, 1, 2, 3 spots. So there are answers, right? Consistent. Not the exact same graph, so also independent. Consistent, independent, consistent, independent. And then let's get to work. We got 3 answers to find. So second calc, intersect. I'll take the left one. Somebody else take the middle. Somebody else take the right. The weirder the function looks, and these are weird looking things, it's got an x cubed and stuff like that, probably the less likely it is that your answers are going to be nice and pretty. So when I did on the left, I got this particular solution. Anybody else get the middle one or the right one? Yeah, what'd you get for the middle? Cool. Love it. You demand. Outstanding. Okay, got 2 of them. I see one more over on the right. And that one seems to be about 1.48 on the x. And on the y, we got ourselves negative 1.19-ish. Works for me. There we go. So you could have lots of solutions. Maybe there's 3, maybe there's 1, maybe there's none. You never know. That's why we graph it sometimes, especially when it's something funky like that. You know, we don't have enough experience with cubes and squares and stuff like that. So not much you can do. Lastly, number 3 up here on the board, y equals 3x minus 5. Y equals negative 2x plus 5. Those are just lines. That won't be anything too interesting. So you go to your y equals, you type them in exactly like they look. 3x minus 5, negative 2x plus 5. First one, you should expect to see a line going up, a positive slope, and the second one, a line going down with a negative slope. So they will cross somewhere. They don't have the same slope. So without even looking at the graph, we can already write the words consistent and independent. These are 2 lines that will definitely intersect, and they intersect right there. So let's figure out where it is. Second count. Intersect. Looks like the answer for this one is 2, 1. Nice clean number on that. X is 2, Y is 1, consistent, independent, and life is good. There you go. All right. So once you got that written down, here's your learning goals for the day. We're going to learn far better methods to solve these. From here on out, I do not want you to solve something by graphing unless somebody specifically tells you to. So next time you'll do that is probably on your test. Probably like one problem or like solve by graphing. Otherwise, I would like you to do these methods we're talking about today, which is a review from Algebra 1, substitution and elimination. Far superior methods. So there's 3 methods: graphing, substitution, elimination. I think by far the most useful one would be substitution. If you don't know what to do, do substitution. Homework due today. Hopefully the internet outage at the end of the day didn't throw you off too much, but your online homework involving solving systems of equations by graphing is due. As always, today's a new lesson, so new homework is assigned with the normal 2-day turnaround on that. So your new homework will be due on Thursday of this week. We'll have one more lesson on Thursday. Tomorrow's a work day, obviously, same old pattern. Today's lesson, tomorrow's work day, etc. Thursday work day or lesson, and then you have a big old weekend to get things done, which is pretty darn sweet. So again, 2.4 is due today, and a new one's called homework 2.5 due on Thursday. All right. Notes, notes, notes. Here we go. We're doing section 2.5 today. Solving systems of equations algebraically, not by cheating and graphing and looking where the answer is. We're going to actually figure it out by hand without the use of any graph. Very, very useful skills. There's some things in math that are, well, everything's useful, but there's some things more useful than others. This would be very useful. This does come up a lot in science and higher things. So found on page 107, and let's get started. So first things first, let's just copy this down if you like things. Here's your summary of how to do something by substitution. This is your second method to know. First one was graphing. What in the world does this thing mean, substitution? Essentially, what you're doing is you're going to solve for one variable. It doesn't matter what. X, Y, typically. Could be A's and B's or W's and P's. It doesn't really matter, but you solve for one variable. And you substitute, replace that variable in the other equations. I'm saying equations plural because eventually we will have 3 equations. Still today, 2 equations. Whenever you do a substitution, you will make your problem simpler. If you start off with 2 equations with 2 different kinds of variables in them, after a substitution, you will be down to 1 equation with 1 type of variable in it that you can solve. Or if you had 20 equations with 20 variables, that would suck. But you could solve for one of them, plug in the other ones, and then you'd be down to 19 equations with 19 variables. And you would repeat, solve for another variable, substitute the other ones. Then And you're down to 18 equations with 18 unknowns. And it just continues and continues. So no matter how ugly of a problem you get, this would be a very acceptable way to solve things. Of course, that's a lot of talky talk. You got to kind of see it done. Take your time writing that down. No rush. What do you mean solve for something and plug in the other equations? Let's see it done. First example from the textbook today says 8x minus 3y. This will be on the next slide in a second, equals -1. And then they give you a second equation where they say x plus 2y is equal to -12. All right. Well, your first step here is to solve for some variable, which means just get some variable by itself. Now, it doesn't really matter where, but which one do you think is easiest to solve for? This x, this y, this x, this y. Which one do you think is easiest to get by itself? I would say this one, yes. So that's what we're going to do. So equation 2, I'm going to solve for x. Doesn't matter which one, but x is pretty easy to get by itself. So x is, if you move the y to the other side, -2y then, and you still got your -12. Whatever you solve for, plug in the other equations. Now, there's only one other equation, equation 1. So what you're going to do is plug this in for, guess what? What did you just solve for? X, right? So you're going to replace this x literally with what x is. X is now -2y minus 12. So here comes equation 1 now, rewritten. Here's the magic. Ready? Equation 1 was 8x. But now I know from equation 2, x is this, right? So I'm going to substitute that in. So instead of writing x, I'm going to write what x is. X is -2y minus 12. So here's equation 1 after the substitution. Have I beat this dead horse enough about substitution? Get the gist? Notice we started off with 2 equations and 2 different variables in them. Now we're down to 1 equation with 1 variable. It's going to take a little work, but now we can go solve for the variable. I think probably first distribute. Would you concur? Let's distribute this thing. So 8 times -2 is -16. So I got -16y. Then when you distribute the 8 to the -12, 8 times 12 is 96. Feel free to use your calculator on these things. So you got a -96 there. Still got your -3y there, and you still got your -1. So just having organization is critical to get through these problems. The concept is not hard. It's just distributing, not letting things disappear and stuff like that. Well, I see like terms we can combine. I see -16 and -3y. That's a grand total of -19y. And while we're at it, let's move the 96 to the other side. If you add 96 to both sides, -1 plus 96 would be 95. So putting a couple like terms together and getting the letters on one side and the numbers on the other side looks like this. Lastly, dividing through by -19. 95 divided by -19, well, a positive divided by negative is a negative. And 95 divided by 19 is nice and clean. It is just 5. So we got our answer for y. Y is -5. Now, if you go look at the directions, after you do your substitution and solve it, you have to back substitute. By that, I mean, now that I know y is -5, I got to go back and figure out what the other one is, x, right? So usually the thing you did to substitute, see how we solve for x, right? That's usually the smart place. You could plug it in anywhere, really. But if y is -5, then up here, x is -2 times y, which now I know is -5 and -12. -2 times -5 is +10, and 10 minus 12 is -2. So now you know x is -2. So to put it all together in the end, my answer is x is -2 and y is -5 Even though I don't see the graph, was there an answer? Yeah, so you write consistent. We're still doing that stuff. So write the word consistent. And if there's no tricks or nothing weird happens in your work, then it's just the normal thing of independent. Independent. And that's how you solve a system of equations by substitution. Solve for one thing, doesn't matter what, x or y, a or b, whatever the letters are, solve for something, plug in the other equations, and then we'll see what happens after that. All right, here's your second example for the day. It's got some decimals in it. I don't know why. Stupid book. Okay, example number 2. Your next equation is going to be negative 5x plus 2.5y jerks equals negative 15. That we'll call that equation 1. I know it seems kind of silly that I keep labeling all these equations, but again, for organization purposes, we're going to need that. Second equation just says y equals and then 2x minus 11. Is one of these letters already solved for? Yeah, they gave it to you, right? Here's y. Y is 2x minus 11, right? So if y is 2x minus 11 in this equation, y is also 2x minus 11 in this equation. So we're literally going to substitute that in for y right there. All right, so equation 1 now will be negative 5x plus 2.5. It used to be y, but y is now 2x minus 11. Make sure you put parentheses when you put a whole expression in like that. You know, the whole thing gets times by the 2.5 right there. And that's still equal to negative 15. So now we have equation 1 kind of simplified down. It's going to be tedious. We're going to have to distribute the 2.5 in and see what happens and stuff like that, but we'll get there. Notice again that now we have one equation with one variable. So every time you do a substitution, it gets simpler. Your life is easier. All right, here we go. Not much to do with negative 5x. 2.5 distributed in 2.5 times 2. 2.5 times 2 is a nice clean number, 5. Yes, it is. 2.5 times 11, 16.5. That can't be right. That makes more sense. Mental math is off today. 27.5. Yeah, that makes more sense. Okay, so you got this. Ooh, now this is a special thing that's going to happen. Check this out. What happens with these 5x's? They just cancel out, right? And you get something out that either makes perfect sense or no sense. Does that make any sense right there? No, that's crap. What's it mean when your work gives you something that's impossible? That means no solution. That means it's impossible that these two equations ever cross. If you get impossible stuff out, it's impossible that they even cross in the first place. So our word for no crossing or no solutions is inconsistent. So this is inconsistent. Didn't need to graph it. If I did graph it, I'm sure I'd see two lines that are parallel. That's how the only way they could not cross. But that's essentially it for that. So inconsistent. Unfortunately, that's the case. Do you think you have a grasp for that, or do you need another example, guys? You good? All right. Let's talk about the third and last method then, and that's called elimination. So here's your last little bit of notes about it. This is a slightly faster way to do a substitution. This is titled elimination because what you're going to do is you're going to add or subtract the entire equations together. So you got two equations, you're going to add them together or subtract them together, and your goal is to have something be eliminated. You want to tweak these equations so that when you do add or subtract them together, one of the variables will go away, will be eliminated. To do so, you might need to multiply your equations through by some kind of number. Maybe multiply one of them through by 5. Maybe multiply another one through by -3, something. Because you want the coefficients, and that's the numbers in front of the variables, to be kind of the same in both equations for whatever variable you're trying to get rid of. The second one says subtract both equations. You could add them. That's equally fine. Add or subtract both equations from each other. After you do that, you'll be down to one equation with one variable again. You'll solve it like normal. And then once you find either x or y, you will back substitute in and find the other one. So really isn't that bad either. Provided you just get the general gist of it. So a couple examples of this also. Once you got the notes copied down, here's your example number 4 on the board right out of the textbook. Again, you're always welcome to go back and look at the examples on your own. That's cool. All right. With elimination, you are not going to go solve for one variable. You're going to try to add or subtract these entire equations together to get one of the variables to go away. Now, what do I mean by that? If you look at these two equations, right off the bat, don't they have the same kind of y's? They got a -9y here and a -9y there. Would you agree? Now, how can I get those to go away? If I add them together, what would you get? What's -9y plus -9y? That's -18y. Does that make it go away? No. What if you subtracted them? If you had -9y minus -9y, would it go away then? What's -9 minus -9? What's anything minus itself? What's 5 minus 5? 0. What's 20 minus 20? What's -9 minus -9? 0, yeah. So if you subtracted these, the y's would be gone. Do you hear that? So it'd be eliminated. So that's what your strategy is. You literally are going to subtract, and I mean the whole equation in this case. You look at it and you think about it for a second, okay, how do I make these go away? If I subtracted them, I would. That means you have to subtract everything. So you do every variable and every number and every letter and everything like that. So here you have -2x, right? From this equation, you're subtracting -4x. That's the same thing as adding 4x, correct? -2x plus 4x would be 2x. By design, the next thing that happens is -9y minus -9y is nothing, correct? That's the point. They have been eliminated. I do not have them. After both of that is an equal sign. You have to do it with the numbers also. So if over here you have -25 minus -23, that'd be -25 plus 23 then, correct? Which would be -2. So now I'm going down to 2x equaling -2. And then just dividing by 2, you get x equals -1. Boom. We got one of them. Once you got one, you got to go back somewhere and plug it in to figure out the other one. It doesn't really matter. We'll go back to equation 1, for example. So back to equation 1. It started off with negative 2x, but now you know x is negative 1, right? So negative 2 right here times negative 1 would be positive 2. So 2, and you still got minus 9y, and you still got negative 25 there. I can go figure out what y is from this. We'll subtract 2 from both sides. We'll divide by negative 9, and it turns out that y is 3 in this case. So we got an answer. The answer is x is negative 1 and y is 3. Like normal, since I got an answer out, it's consistent. There was no weird things that happened in my work. What do weird things mean? I'll talk about that another time. Consistent and independent. And we're pretty much done. That's all there is to elimination. Okay, so let's think on the next one. That one was kind of a softball because they right off the bat, these were the same kind of thing, correct? 9y's and 9y's. So I didn't have to do anything. I just had to think about, do I need to add or do I need to subtract to get rid of those? This next one will not be quite so easy, but not that horrible. So this is example number 5 out of your textbook. Again, they're going to give you 2 equations. First one is 2x plus 5y equals 1. And the second one is 3x minus 4y equals negative 10. Okay, now if you look at this one, the things in front of the x's aren't the same, are they? Shoot. The things in front of the y's aren't the same. Shoot. So we're going to force them to kind of be the same. Now, I want you guys to pick one. What do you want to eliminate? What do you feel like getting rid of, x or y? Pick one. Y. We're getting rid of y. If I'm going to get rid of y's, then the numbers in front of the y's have to be kind of the same, right? So what I'm thinking is maybe we multiply the top equation through by 4. That would make this 20 then, right? And if we multiply the bottom equation through by 5, that would make this 20 kind of also, right? So that's what we're going to do. Let's change both of them by doing exactly that. The first equation, multiplying everything by 4, we would get not 2x, but 8x, not 5y, but 20y, and not 1, but 4. So every number, every term got scaled up by a factor of 4. Second equation, we decided to multiply everything through by 5. So 3x times 5 would be 15x. Negative 4y times 5 is negative 20y. And negative 10 times 5 is negative 50. Okay, so you can add or subtract these equations. Which one would eliminate the y's? Do I want to do 20 minus negative 20? Would that get rid of the 20s? 20 plus negative 20 would get rid of it, correct? So this time we're going to add this entire second equation to the first one up there. And we go term by term. So we got 8x's plus 15x's. That would be 23x's. We got 20y's plus negative 20y's. That's nothing, correct? That's why we did this. So it would be eliminated. So there is no y anymore. And over on the right side, 4 plus negative 50 would just be negative 46. And when you divide through by 23 on both sides, negative 46 divided by 23 is a nice clean number of negative 2. So x is negative 2. Then we'll go back somewhere, doesn't matter where. How about here? Why not? Any equation will work. So if I go back to equation 1, it said 2x, but I know x is negative 2 now. And 2 times negative 2 is negative 4. So there's equation 1 with x being replaced with negative 2. I can solve that. We'll just move the 4 to the other side. Adding 4 to both sides, you get 5y equals 5. And dividing through by 5, finally, that means y equals 1. So my answer is, I like to put everything in a nice little box when I'm done. There's my answer. X is -2 and Y is 1. I got an answer, so it's consistent, right? And independent also. You can always assume it's consistent and independent unless something weird happens in your work. How about something weird happen in your work? All right, let's try one more, then we'll call it a day. Maybe quickly talk about what could happen in your work that would be weird and what it would mean. But here's the last formal example, example number 6 today. We got this system of equations, 18x plus 21y equals 14. Second equation is 6x plus 7y equals 2. Again, it's kind of up to you what you want to eliminate. What do you feel like, x's or y's? X's. Okay, we want to get the x's to go away. So we need to get the numbers in front of the x's to kind of be the same. Now, this one's already 18, right? 6 times 3 is 18, right? So why don't we just take the second equation and multiply it through by 3? Then they'll have the same numbers. Equation 1, not going to do anything to that, but let it chill. Equation 2, after multiplying every single thing through by 3, you get 18x. 7y times 3 would be 21y. And over on the other side, 2 times the 3 would be 6. Okay, so now the things in front of the x's are the same. That's what we want. We're trying to get rid of the x's. How do I get rid of these? Add them or subtract them? I'd subtract them, right? Don't add them. That'd give me 36x. So we're going to subtract this entire equation from this one. 18x minus 18x is nothing. 21y minus 21y is also nothing. So there's nothing left on this side. And over on the right, we got 14 minus 6, which is 8. Now, we came into this a minute ago. What happens when you get something that makes no sense? There's no solution, right? So write the word inconsistent. Inconsistent. So you might want to make a note to yourself. When you get out something that makes no sense, that means there's no answers. What happens if you get out something that makes perfect sense but doesn't give you an answer? So here's your last little tidbit for today. Let's say I gave you these two equations, x plus y equals 3, and another x plus y equals 3. Aren't those the exact same equation? What's going to happen on the graph then? They're going to cross everywhere, right? Infinitely many places. What would happen in my work if I was doing this kind of stuff? Well, if you wanted to eliminate the x's, you'd subtract these. Would you agree? So if you chose to do elimination on this and you subtracted them, x minus x is nothing, right? Y minus y is nothing, right? And over here, you get 3 minus 3, which is also nothing. Now, that doesn't give me an answer, but is that true? Is that always true? Yes. So guess what these two graphs do? They always cross. When you get out something that's obviously true like this, that's a clue to yourself that this thing is consistent, but not independent, dependent. When you get like 5 equals 5, or you get out 20 equals 20, or 0 equals 0, something that is clearly true but doesn't give you an answer, that means consistent and dependent. When you get out nonsense, that means there's no answer whatsoever. Feel okay on this stuff, guys? I think so. Hard to gauge exactly, but I know 60 or 70% of you feel okay with it, so that's good. All right, and that's pretty much it for the day. You got homework 2.4 to work on, do. You got homework 2.5, that's the new one. That's over what we just talked about, solving these things with substitution or elimination. So you got a good 10, 12, 15 minutes left or something like that. You can go ahead and get something done. Good work, everybody.